Hello, Math for Teachers 2 students. This is the first of several videos that will be an overview of our lessons 9 through 12. First thing I want to do is remind you to go into Tools and Announcements. There was an announcement for week 8 that was posted, so you want to go into there. Another quick reminder is to go into and click into our revised course schedule. Taking a look at this, we are now at week 8. We know there's no class this week due to reading days. You do have your project 2 due this Wednesday, and you will have an exit ticket specific to the lessons that will be reviewed in these videos. Next week we do have class. We will be looking at lessons 13 through 15, completing an exit ticket, and we will do the quiz 5 together in class. It'll be an in-class collaboration in class. You don't need to bring anything, just yourself and a positive attitude, and we'll do that quiz together in class. Okay, we've clicked into lesson 9, which is multiplication of rational numbers. Just a reminder that it's always good to review the various materials that are available for you, in particular the overview, as well as the applications at the end. We'll give you supplemental information. Let's dive into our slides. Okay, again, this is lessons 9 and 10, multiplication of rational numbers. By the end of this class, our learning objectives will be the following. Recall the meaning of multiplication discussed in Math for Teachers 1. Deepen our understanding of the difference between a fraction as a measurement and a fraction as an operator. We will begin to think about how to model the fraction as an operator with diagrams, linear, area, and discrete models. We will also use the all at once and by place meaning for multiplication to model fraction multiplication problems when the multiplier is greater than 1. Okay, remember you can always come back to this video, and I will also be posting the slides. So first things first, what is multiplication? And to dive deeper, what is an algorithm and what is repeated addition? So we're going to look at some videos together. You may want to take some notes. I hope that these are helpful.
In this video, we will begin our discussion of algorithms. An algorithm is a finite sequence of steps for performing a task. By finite, we mean that the algorithm ends eventually and does not continue to run forever. Some examples of algorithms that we use in our everyday life are cooking recipes, driving directions, and, for our purposes, carrying out a mathematical task. An algorithm consists of 3 parts, as illustrated by the diagram below: the input, the finite sequence of steps, and finally the output. As we mentioned previously, an algorithm runs in a finite number of steps. It wouldn't be very practical to have an algorithm that never terminated. In order to control when an algorithm stops and what the outputs of that algorithm are, we use return statements. For example, let's say that we wanted to take 2 numbers, multiply them together, and then add 4 to that result. We could design an algorithm with the inputs a and b, and the output a times b plus 4. Our algorithm then would consist of the statement return a times b plus 4. Here's an example to try on your own. This algorithm accepts the integers a, b, and c as input and returns the numbers 2 times b, a plus b, c squared, and b plus 2 as outputs. Use the following values for a, b, and c and see if you come up with the same answers that we did.
Okay, so here are those examples again. Hit pause on this video. See if you can solve the input. Now check your responses. If a equals 1 and b equals 2 and c equals 3, 2 times 2 is 4, 1 plus 2 is 3, 3 squared is 9. And 2 plus 2 is 4. Let's do one more together. Let A equal 2 and B equal 6 and C equals 0. So if we're doing A equals 2, B is 6. Remember, our return is 2 times B. 2 times 6. A plus B. 2 plus 6 is 8. C squared, in this case C is 0, so 0 squared is 0. And finally B plus 2. B is 6 plus 2 is 8. I hope these back and forth slides allow you to take time that you need to digest and confirm that you understand this information. The next video we're going to watch is about multiplication as repeated addition.
So as some of you already know, I really enjoy eating a good avocado, which despite its appearance that it looks like a vegetable, but it's actually a fruit. And let's say that I eat 2 avocados per day, and I eat 2 avocados per day for 6 days. Now, there's a couple of ways that I could think about how many avocados did I eat. I could say, hey, I eat 2 a day, and I'm going to do that for 6 days. So I'm going to add 6 2s together. So it'll be 2 plus 2 plus 2 plus 2 plus 2 plus 2. I have 6 2s right over there, and then I can add them together. And we could say 2 plus 2 is 4. You add another 2, you get to 6. You add another 2, you get to 8. You add another 2, you get to 10. Yet another 2, you get to 12. And that all is fine. But there's an easier way to express this repeated addition. One way is to view it as multiplication. Instead of just writing out 6 2s and adding them together, mathematicians have come up with a neater way of writing that. They'll say, okay, we're going to add up a bunch of 2s. How many 2s are we going to add up? We're going to have 6 of those 2s, and we need to come up with some type of a symbol for it. So we will use this X-looking thing. And so 6 times 2 can be viewed as repeated addition in exactly this same way. So 6 times 2 would be equal to 12. And we could go the other way around.
Okay, it's not an X thingy, it's a multiplication sign. So again, as we're learning the teacher script, you want to hit pause. Not every video is perfect, and that's why stopping and reviewing it and assessing it is very important. Okay, let's continue.
And we could go the other way around. If someone were to ask you, what is 4 times 3? Pause this video and see if you can write it out as repeated addition, like we saw up here. Well, one way to interpret this is to say this is 4 3s. So we could say this is equal to 3 plus 3 plus 3 plus 3. And 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is equal to 12. You might be familiar skip counting, and you would say 3, 6, 9, 12. Just out of curiosity, what do you think 3 times 4 is going to be? Pause this video and try to represent it as repeated addition, and then see what you come up with. Well, we can interpret this as 3 4s, and so we could say this is going to be 4 plus 4 plus 4. And if we skip count 4s, we'd have 4, 8, 12. I was about to go to 16. 4, 8, 12. So this is going to be 12. So this is interesting. At least for this example, for these two examples, I got to the same thing. 4 times 3 got me the same result as 3 times 4. Interesting. I wonder if that's always true.
Okay, a few things to point out on this video. Notice that the speaker is using different chalk colors, right? Green to represent 2, and then the total of, and then he switched to 6 in white times 2, kept that green, and that new total is in white chalk, 12. And then when he did 4 times 3 and 3 times 4, again, he's using the same color for 3 versus 4 to show the differences. Also notice that the 4s trailing at the end, the last 2 4s, look more like the letter Y, and not really great Y's at all. So you want to be mindful. It's hard to write 4 plus 4 plus 4 and repeated addition, but slow down, okay? And as a teacher, you want to model the best printing of alphabet letters as well as numerals. Okay, we're going to move on and we're going to look at number sentences. So in this case, the word problem is a recipe for a batch of muffins calls for 1 1/4 cup of raisins. If Thomas wants to make 3 batches of muffins, how many cups of raisins does he need? So the questions here are, what is the number sentence that would solve this problem? What is the meaning of this number sentence? And how would we draw a diagram that would match this meaning to solve the problem? So, take a few minutes and see if you understand the concepts of number sentence, meaning of the number sentence, and a diagram for this word problem. Okay, so you had time to write that out as far as the muffins and the raisin amounts that Thomas will need to bake his muffins. Okay, keep that paper, right? Pull it aside. We're going to move on. This is Paul's wool scarf has 8/9 yards long. Paul's wool scarf was 8/9 yards long. After he put it in the washing machine, it shrunk to 1/4 of its original size. How long is Paul's wool scarf now? So the number sentence that, what is the number sentence that would solve the problem? 1/4 times 8/9 yards. What is the meaning of the number sentence? 1/4 times 8/9. And how would we draw a diagram that would match this meaning to solve the problem of 1/4 of 8/9? Right? And you'll see the fraction bar below is a hint. Okay, we're going to pause and I'm going to stop this first part of lesson 9 in the video. So this will conclude part 1. Please take time to write the questions down from the previous slide and this slide. Look at those word problems and see if you can solve the number sentence, the meaning of the number sentence, and then the diagram of it.